also not going to talk about when it's appropriate to use these various different types of plots. That's something, excuse me, hopefully you've learned in some other class. But I'm just going to walk through these quickly to give you a sense and talk a little bit about the different parts of the command here. So first, we talked about our norm command, where you're creating a vector of randomly drawn values from using these parameters. I'm creating here, the code I'm creating is just a template where whatever it is you want to make a histogram of, you can call X. So if you assign the thing you want to plot to X, you don't have to change your code all the time. And so the central command is this. It's the hist command. So if you do $hist, it'll pop up all of these different things that you have controlled in terms of changing. You have main here, where you can change the text that you want to show on top. You have the limits, the range of breaks on your x-axis and your y-axis. You have the labels that go on, all of those different sorts of things. Here I'm also telling it I want the bars in this histogram to be colored red. I want the axes to be true. So if I plot this, something went wrong there. I wonder why that happened. I've never seen R do this. What am I doing wrong? I've literally never seen R do this. I don't know what. Okay, keep working for a second on the assignment. I'm going to figure out, somehow my margins got really messed up, so I'm going to see if I can figure that out here. Quite unfortunate if I'm trying to make you drink the Kool-Aid and tell you that R's graphic capabilities are really great, and then I can't get it to do what I want it to do. That's no good. I don't know where it's reading its default margins from. Okay, I have no idea what's going on. So, is it working on your machines? Or is something, when you plot, working fine? Okay, okay, do you mind if I just use your machine?
Yeah.
I'll figure that out.
I'm just gonna grab the issue, right? And just make this.
Thank you. Sorry.
That's fine.
Okay, so this code over here, you are calling the HIST, you're telling it to plot this vector of the, for example, test scores here, assigning the color, assigning the labels, and you should get this nice normal histogram over here. Now everyone's histogram is going to be slightly different because you're doing a random draw from this distribution, so your histogram won't look exactly like this, but it should look approximately like a mean of the 4, a standard deviation of 4. Okay, the next code is bar graph code. I need to rewrite this. This is very clunky code, but it's just to give you a sense for what you can do with a bar graph, and whenever I get around to fixing it, I will send that out or post that. The basic idea here is that you are again making a placeholder table for the values that you care about, and then you're filling it with different values. So in general, you want to avoid doing this by hand. Ideally, you'd be pulling these values out of a t-test or out of something else that you've been running. But in this case, we had values that we knew for the proportion that had logged in, I forget whatever this was. I guess this was some data that Meg gave me as an example. She found in one group, 27% of people showed up to volunteer, and in another, 3% did. So here she's putting in the proportion of group 1, the proportion of group 2. She's calculating the difference between those two proportions, and then she's calculated the 95% confidence interval for that difference and was putting it into those two values. She's then assigning a color vector. And for those of you who like color, this is a fun part of R. One of the things I sent out was a document of all the names of the colors in R. You can choose whatever you want. And then here you are making this difference between them. You want it to be on the scale of 100%. And so you're using the bar plot command. So you're telling it you want the this login diff table that we've made. You want it to do columns 2 and then column 1 in that order. You want them to be next to each other. You want those colors, and you want these labels to look like that. Okay, so that's partially what we want, right? We've told it to suppress several things because we want to have more control over what the output looks like. So now we're adding in all of the details. So this axis command is the 4 axes of a plot. Sorry, violating your privacy here. So this is side 1. That's side 2, the top is side 3, and the right side is side 4. Okay. And here we're telling, so let me put it up and then I can show you what it corresponds to. Do you want me to dismiss this?
Sorry. You're not disturbed.
Okay, so now it's starting to look a little bit more. We've got a label here, we've got axes here. This corresponds, notice we're telling it on the side 2, on the left side, on the at is where on that axis you want to sequence from -1 or -0.1 to 0.5 by this, and you wanted to print these labels on there. All of these different commands in here are different controls you have. So for example, font equals 0.2 corresponds to setting something as bold. This par command is the name for all of the things that you have control over within your plotting commands. And if you go through here, it describes what all of these different adjustments are that you can make to your plots. Adjusting the size of points, adjusting the size and width of lines, colors, anything and everything you want to change. So what I encourage you to do to learn functionally what all of these things mean is to take this code that is clunky but quite straightforward and play around with all of those different parameters so that you get a sense for how changing those things changes the output that you end up with. The next part here is the text command. If you want to add in text into the actual plot window. So here, this was the value of the difference between them, the confidence interval. And on this text command, these numbers here are giving the X and Y coordinates within the window that you want, where you want the text to be going. And then your, here's that paste command that we saw earlier where you're telling it to paste different things together. So you're pasting values with a percent sign and then a dash. If you read through this line right here, you're pasting all of that right there. You're just pasting different things together. You're pulling in values and pasting in some fixed text there. And then this segments command is used for plotting line segments within a window. So she's plotting the confidence interval of the estimates of the effect here. And so you can see that they don't overlap. One extension here is that you can pull out elements of a t-test that you run. So as a general rule, you want to avoid coding things like this with fixed values. It increases the possibility for a mistake. So if we run a t-test here, this is looking at feeling thermometer for scores for Justin Bieber and whether or not you want to deport him. And so we create this object called beads. It has all of these different elements to it, and then you can call the particular elements of it. These things can then be fed into your table that you're creating to be able to use for your plot. So instead of coding in a fixed number, you can code in, the confidence interval values that you came up with. Okay, the next one here is a correlation plot. Here, I don't know what my theory was, but I thought perhaps there was some relationship between your thermometer scores for the food in the calf and your feeling thermometer scores for Sadler. So this, again, I encourage you to just play around with these different parameters. But I'll put that up there. So, yeah, it looks like there's some relationship. But those dots right now are fairly uninformative. We may, depending what you're doing, if you don't need to protect your subject's identities, you may want to do other things. So for example, this is the if-else command. This is the command I introduced at the very beginning of class. If-else, so here's a test. if else, and this variable, if it is equal to the value of 2, you should fill in the value blue. If it's not equal to the value of 2, you should fill in the value of red. So what you end up with for our gender normative vector, we're on the sociology floor, so I have to say that. If you have created your gender normative vector, this is going on the web, isn't it? Okay, so you end up with this vector of reds and blues, which is then corresponds to your data points. So what we're doing in this loop here is we want to add text, but we are looping through in order to add text to the points on our graph. So we're saying take we're looping through all of the rows in our data set, and we're saying take the ith value, whatever the value of I is for the CAF food rating, that's where the X position is, and here's for the Y position. The label should be the name associated with that, and the color should be the red or blue associated with that. My theory here had to do with the fact that male college students are generally less picky about their cuisine, so maybe we'd see higher ratings among the men. So, this is all of you guys. My theory, not always correct, Sam. But for the most part, it looks like the red guys in our class seem to have higher ratings for the food and for, yep, and then if you want to do a line just to see the strength of the relationship here, you can plot that line then as well. Okay, the last 3 minutes, just a few other plots to show you and a couple other points to make. Okay, this is geographic distribution. This is the proportion in our class, the proportion of the class from different states. So what I did here was I created a table of the states, and then I divided it by the length of that vector that was complete. So the exclamation point means is not. So is not NA means the ones that are not NA. And then I ordered that so that the top proportion would be the greatest. And then I reordered that vector to get the state proportion. I assigned a color here. And this dot chart sets up all the rest of that. The labels and all of that sort of thing. Okay, it's actually, this code is wrong. It says that DC is on there twice. I guess that's correct. So someone just put in as Washington, unless they're actually from the state of Washington. Is that you? Mm-hmm. Does anyone in here actually put in Washington? I think DC is on here twice. There's also something funky you'll notice. So Virginia is on here twice. And this is one of the annoyances of R. It can be helpful in certain instances, but it can be super annoying in other instances. So if you look at this, if you look at the table for that, you'll see what's going on here is that Virginia is actually appearing twice. Now, if you look, it's really a little bit hard to tell, but notice how on all the other ones, the end of the word lines up with the number, and there's a little space there. That means that someone, when they were filling out the survey, put a space after the word Virginia. And R is going to take input very literally. And so it thinks that Virginia with a space after it is different than Virginia without the space. And so sometimes there's no choice on these things but to go back and correct it by hand. In this case, I think the easiest thing to do would be to go in your CSV file, find it, delete it, and read it back in. There are ways to manually do it. Okay. Last thing, saving your plot. To save your plot, click into your Quartz viewer window over here and say save. And then you always want to make sure what the default is this R plot right there, that you're not saving your console window. If you go over here into R and you forget to click over here and say save, and it says console, you think you're going to be saving your plot, but you're actually just saving all of the output, and you'll be very sad later. If your code, if you have good records of your code, it won't matter because you can always just go back and recreate what you did. So that's why it's really important to keep good code. Okay, the last point here is that there's so much more. Like, this is really just the very beginning of all of the capabilities that R has. I've put some more links up here for other things that you might want to do in R. More of the controls. You have plotting multiple plots in a single window, adding legends, some inspiration for neat ideas. Last year, some folks had interests in time series analysis and reshaping data sets. From here on out, it's going to be up to you to investigate and figure out what it is that you need. I would love to serve as a resource for you, so please don't hesitate to get in touch with me and ask me questions if you're struggling with something. Hopefully, if you don't know anyone else in this class coming in, you've met at least a few other people that will be able to be helpful, and we have the office hours next Wednesday, a bit earlier. Emily's and Zach have put together a really great page called the R module on the center's website that's got these videos. If you really are missing my voice and just want to go through this whole thing again, you can watch those. There'll be a bunch of other resources on there as well. But I really encourage you guys to stick with it. It's a good skill to know. The startup costs are really high in the beginning, but I think the payoff is worth it in the long run. So that's my inspirational plea. Stay in touch. My lab, we're meeting downstairs in 37, and Godspeed to the rest of you. Have a good night.